Welcome. In this short video lecture, we're going to discuss about how to find a sine Fourier transform of a function. My name is Vincent. I teach mathematics at the School of Engineering, University of Nairobi. So here is the problem. To find sine Fourier transform of the function f of x given by x squared for x between 0 and pi and 0 elsewhere. So this is a piecewise defined function, but then because this other portion is 0, then really we don't concentrate on this one. We only take care of the one that doesn't give us a 0, which is x squared. But before we start solving the problem, let's remember that the sine Fourier transform of a continuous function is given by, so we write sub s of a function f of x is given by square root of 2 over pi 0 to infinity of f of x multiplied by sine of kx dx. So this is the definition of the Fourier sine transform. So we are going now to use the limits given in the equation and the function defining the function in this section, and then be able to evaluate for what is being asked in the question. So sine Fourier transform of f of x is given by the square root 2 over pi integral from, now this limits from 0 to pi, and then the function is x squared, and then sine kx dx. So this is what we are going to evaluate. And if you check this one here, that integrand can be evaluated by parts. So we use integration by parts formula. So integral from 0 to pi, so we have 2 over pi, so this is f sub s, is given by so x squared sine kx dx. So we let u to be x squared, which tells us that the u will be 2x dx. dv is sine kx dx. And on integrating this one, we get v to be minus cos kx over k. So using the integration by parts formula, which is given by u dv equals to uv minus integral of v du, we have that sine Fourier transform is a function of k will be square root of 2 over pi into, so uv will have minus x squared cosine kx over k, limit from 0 to pi, minus v du, but because v is negative here, so therefore the sign will be plus. Then integral from 0 to pi, and then du is this one, so we'll have 2x cosine of kx divided by k dx. So that's what we have. And then Next, we'll have the Fourier sine transform of function we have is 2 over pi. When you put in the upper limits, we'll have minus pi squared cosine of k pi divided by k. By the lower limit, this is be 0, so will give us 0. And then plus, I factor out 2 over k because they are constants, 0 to pi, and then x cos of kx dx. So that's the next step. So the only problem is at this point here. So we also use integration by parts formula. IBP means integration by parts formula. That's the notation I'm using. It may not be standard, but that's what I mean. So I'll have the Fourier sine transform of this one is 2 over pi. Now, here we let u to be x, which means du equals to dx, and we let dv to be cos kx dx. On integrating, tells us that v will be sine kx over k. So uv, so this first one will be minus pi squared cosine of k pi over k, and then plus 2 over k into, so uv, I pick this my v, so I have x sine of k x over k, limit 0 to pi, minus integral of v du. So my v is this, so I have 1 over k, integral 0 to pi, and then sine kx dx. So I close the bracket here, and then this is what I have. So that sine Fourier transform of the function is square root of 2 over pi minus pi squared cosine k pi divided by k plus, now sine of, so remember this put for x. So when I take pi times sine of pi k, I get 0. So this part will give us 0 because sine of multiples of 180 degrees, all of them are 0. So this part will be 0. So yes, I have minus plus times minus is minus. So I have minus 2, and then this will be k squared, integral from 0 to pi of sine kx dx. So f Fourier sine transform of the function will be given by square root of 2 and then root 2 over pi minus pi squared cosine of k pi over k, and then I minus 2 over k squared, and then we integrate sine this one and get minus cosine kx over k. I put in limit 0 to pi, so that's what I have. So that the sine Fourier transform of the function is square root of 2 over pi minus pi squared cosine k pi over k, minus minus is plus, so 2 over k power 3, and then upper limit I'll have cos and then pi k or k pi. Then minus. So when I put 0 here, so cos of 0 is 1. So 1. So this is what I have. So I'll have, this is what the solution that I have. But remember, cos k pi or cos pi x has two values, 1 when k is even and minus 1 when k is odd. And what can bring all this together is simply saying -1 raised power k. So then I can say the sine Fourier transform of the function is the same as square root of 2 over pi, and then into brackets minus pi squared over k, and then the place of cos k pi I put -1 raised power k plus 2 over k power 3 into 1, and then into -1 raised power k minus 1. That's what I have. Or you can as well write it as sine Fourier transform is root 2 over pi minus pi over k, and then -1 power k minus 2 over k power 3 into into 1. Should be the same things. 1 minus -1 raised power k. So this was the solution to the problem given. Either this or this are the simplified expressions for the Fourier sine transform of the function that was given in the question. Then you get your full marks. So thank you.